Hello, this video is about Earth curve calculator and also about calculating the Earth curve and observing the Earth curve are two different things. You can come to GiftHub Earth Curve Calculator and you can punch in how tall you are or how tall the building is and then how far you want to see out, and then it will tell you how much of the curve how many feet the curve is hiding from you. So say I'm 5 feet tall, I want to see 10 miles. The calculator says that I can't see 35 feet because of the Earth's curve, or this hump right here, the curve. Now this is a mathematical equation. They cannot figure the Earth's curve out any other way. They have to put it in with a line next to it. Now the circle and the line, never the two shall meet. They are complete, well, they're 50% opposite of each other, really. They have to measure the circle with a line by it. That's how our vision works. That's how we see as humans. So we will, of course, want to measure things with how we view them. So they have to measure the circle with a line. It's a mathematical problem. That's just how it is. Now, that can calculate a circle, yes. That is the mathematical equation to calculate a circle. But when you calculate it, that's fine and dandy. But when you're observing a circle, it's a completely different thing, especially if you're supposed to be standing on top of it. If you are standing on top of a circle, you're going to be right here. You're going to be standing right here. Or you're going to be standing over here, you're going to be standing over, but you're going to be standing on this circle, right? So when you look out, you're going to be looking straight out. You're going to be looking straight down. You're going to be looking straight up. You're going to be looking straight sideways. But that's how you're going to be looking. You're going to be looking straight. So here you are standing. If we are standing on a globe, this curve is going to go just like this diagram shows. It's going to immediately start dropping off away from you. Just like that. Now, if you were standing on a flat surface, it would go out from you like that. That's what it would do. It would go straight out from you. And your eye would where? Your eye would meet it down here, right? But if you're standing on a ball, and the ball's curving down that way, your eye is going to look straight out, right? But it's going to have to look down. It's going to have to look down. You can't get away from that. Your eye will have to look down. We would see this very easily in the desert, say from a palisade, which is a desert mountain. You would be able to see the horizon in the desert. So you have to see the horizon. You can't just look down your street or anything like that. You have to see the horizon. That means in the distance, say on a beach or in the desert or on a lake, something like that. You have to be standing so where you can view the horizon. So the horizon, if we were on a ball, it would always curve down. Now, if the ball was super, super, super big and we were super, super, super tiny, you may not be able to notice it, but you would be able to notice it from a mountain, a tall building, an airplane, all those things. You'd be able to notice it. Say a drone. All those things would be able to notice this curvature. It would be simple to see. Our Earth, the Earth the globe is calculated to be over 6,700 kilometers, a little bit over that. So we would be able to see it easily. I put the math in the calculator. It says if I was 5 feet tall and I wanted to see 10 miles, I would not be able to see 35 feet of the Earth's curvature because of this hump, because of the curve in the Earth. This calculator says that basically my horizon distance is 2.7 miles out right here. I'm supposed to be standing here, and right there, that's when the Earth starts blocking out everything. 2.7 miles. We know that this is inaccurate information. There's a camera. It's called Nikon P900. You can go to Wide Awake's channel, and that's all he does is use this camera to view the horizon. He does spectacular work. There's another gentleman, Adam. Adam IFE is his channel. And he does the same thing with this camera. This camera can see way beyond the Earth's curvature. If that was true, if this math was true, if this curvature math was true, this camera would be able to video and take pictures around a corner. That's impossible. It's impossible. You know, this math is ages old. This curvature thing is ages old. It is. And our technology is so much more advanced now. It is. They shouldn't be teaching this in school anymore. They should not be teaching this to people. It's inaccurate. You can go down and buy a $500 camera and figure it out for yourself. Anyway, I would like to know where the research came to put the 2.7 horizon distance in here. Where's that research coming from? We know that that's inaccurate because of the new technology that we have with cameras and lasers. We know it's inaccurate. So why are they still teaching it? Also, look at this H1. That's the measurement they're saying that, you know, that's how much curvature that's how much Earth you're missing because of the curvature that you can't see. Well, if that was true, this is just, let's just say this is just 10 miles. Let's just say this is my 10 miles that I asked for. If this was the Statue of Liberty, look how she would be facing. She would be facing back from our point of view right here. We would be able to see her. We'd be able to see the top of her. If we were standing over here, she would be facing back. We would see that in movies. We would see buildings doing it, in books and videos. People would be putting it on music albums because it would be so cool to see. But we don't see that. We don't see that because it's not there. It's not there to see. So there's lots of different ways to evaluate our information. And just because it's in a book, or just because somebody with authority is teaching you, does not mean it's accurate. You know, school, I remember them teaching me to always think for myself, always think for myself, always think for myself. Well, what's interesting, when people in the flat earth community have started to question and think for themselves, the educational system is the first people to stand up and go, you're wrong, you're thinking wrong. Your calculations are wrong. Your camera's bad. Your camera's out of focus. You can't calculate simple math equations. What you're seeing is pretend. You know, it's very strange. It's very strange to discover that the Earth is flat. Yeah. Kind of broke my heart a little bit to find out what happened, what has happened, what is happening right now. Anyway, thank you. Have a good day.